This is the real Tom Rose, and we're asked to find the roots of this is a cubic, actually. It looks like, so we have a binomial here multiplying a quadratic, right? We have an x to the first term in this one and x squared in the other. What they're asking you for is the roots of it. It helps to know what they mean by roots. Sometimes you'll hear this word when people are asking you to solve quadratic equations or something. When they say find the roots, that's code for find the values of x that make this equation true. It's like saying solve the equation, right? So this is a special equation though. It equals 0. That makes it much easier to solve because the values of x that make this work are the values that generate a 0 term somewhere in this. So let's start out by looking at the left side of this specifically. If x is equal to -1, hypothetically, right? Then this term, x plus 1, will evaluate to -1 plus 1, right? Which is equal to 0. So when x is -1, the whole left, or like this term becomes 0. But 0 times anything is 0. So it doesn't matter what the quadratic is. So as soon as we see that x plus 1 is 0, we know that this equation is going to be true. So x is equal to -1. That's one of the roots. So we can get rid of anything that doesn't have that -1 right away. Now, you can kind of ignore that x plus 1 part of it because we've already found the number that makes that 0. What we need to do now is look at the quadratic and say, is there anything that makes this 0, that makes that 0? So how can you do this? Well, factoring is a good way of converting this into binomials, which are much easier to evaluate for zeros. So let's do that. So we want to factor this. And when you factor a quadratic like this, you want to, let's assume that we're splitting it up into a binomial. And since the first term is x squared, we know we'll be multiplying x by x at some point. And we really need to just find the two values that fill out the rest of these binomials. And so we're looking for an integer value now. And we're looking for two numbers. And the two numbers that we're looking for to fill these two holes, they need to multiply together to give you the numerical only term. And they need to add together to give you the coefficient on the x term. So what two numbers, when you multiply them, give you -5, and when you add, give you +4? It must be, there's only one case that does this. It must be x plus 5 and x minus 1. Right, if I multiply those, I get -5, and if I add them, I get 4. So this is part of our new equation now. I'll rewrite the whole thing. And we're looking for values of x that make either of these equal to 0. So values of x that make this 0 are x equals 1, I can see, because 1 minus 1 is 0. And also x equals -5 will make that 0. So we're looking for x equals -1, x equals 1, and x equals -5, which is that one. And we can eliminate the others.